have a look on assignment 2. You can read it later on your own at your home. And I just want to a little bit briefing on assignment 2. Okay. So assignment 2 basically is it's called a project basically, not assignment. We call it a project basically. That's a small project. So the project is I think you're gonna have to develop your deep learning project. Okay, and say if your data set is rambutan, your title can be rambutan classification using deep learning. Okay, so this can be your title, or nasi classification, Malaysian rice classification using deep learning. Okay, so put Malaysian there. All right. So in this case, I put example of rambutan classification using deep learning, because the word rambutan is always known as in Malaysia only. If you see rice, then you see Malaysian rice classification system. Okay, so it's more specific. So you can change your title basically as long it within the context, within the problem definition and context. So the first thing you're gonna do on your assignment, project basically is once you pick the title, this case say rambutan classification using deep learning, then you need to develop a CNN model, convolutional neural network model, which we learned last few weeks. Okay. So in this case, if you put rambutan project has 4 types of rambutan, then your classes will be 4. If you got rice project, if you got rice, your type of rice is 6 or 5 or 7. There will be your classes. Okay, and so you're going to develop the CNN model, and the way you develop is just on you got free on your choice how many convolutional layer you're going to use, how many neural network you're going to use, how many. It's up to you on how many convolutional layer you would want to use. So convolutional layer basically is for feature extraction, and for classification you use dense layer, and it is free of your choice how many layers, how many neuron. Okay, and I think the bigger. Okay, your CNN model must be large enough, not too simple like LXNet architecture. We're gonna look at LXNet architecture. In this case, for example, you got 4 or 5 layer of convolutional, and you got at least 2 or 3 neural network layer. Each layer contain about 1,000 nodes. Okay, so that's large enough for your CNN model. And use your creativity to design your CNN model. Okay, it's not specific. You have to do 4 convolution layer, up to you. You can put 5, 6, and so on. Then finally, train and testing your model from rambutan dataset or rice dataset, and get so many epochs and get the best accuracy. So experiment it with different configurations, such as changing the epoch, optimizer for the best experience and for the best accuracy, and use CRUS. Okay, use CRUS. From now on, use CRUS. Okay, remember that. Okay, because CRUS is simplify our work. If we use TensorFlow, it's gonna be a long coding to do. So these are, for example, of CNN model you're gonna develop basically on your CNN. So in this case, example, I got 1, 2. I got 1, 2 convolutional here. Okay, I got 2 convolutional, and I got 1 layer 256. This is an example. Okay, this is an example, and your class will be depends on how many classes you got on Malaysian rice or rambutan. In this case, rambutan you got 4, 10 classes you got 4. Okay, and the rest is up to you. Use your creativity here. All right. So this dropout, basically I just put it there. Okay, you can delete this one, up to you. Dropout 0.5 means you're gonna drop 50% of your neuron from that layer. So 256 it become 100 something, 120 something nodes. Okay, then the first you're gonna have develop the CNN model. So this is just a few line of code if you understand. Then the second one you're gonna have put two more model for your prediction model, which is use transfer learning model such as VG, G16, LXNet, MobileNet, and extra. So once you use this, and again you're gonna test and train your transfer learning model of rambutan dataset and get best accuracy. Experimental with different configuration, epoch, optimizer, and so on. And then again use CRUST. So the third one you're gonna compare these two model or three or four compared to the CNN. Okay, so just compare them in terms of accuracy, plot some accuracy figure and so on, and you're gonna say the performance accuracy of VGC16 and my proposed CNN is not much any different, so on, blah blah. So at the end of the day, you're gonna write a report model you have using. So you're gonna write a report on all of these things using the format below. So this format basically will get you on report content. So you are freely creative to enhance this report. So this report basically is guidance for you. All right. So your report is just like a paper like this. Okay. So in this case, you got Malaysian rice classification using deep learning and transfer learning, something like that. Okay. Or you can say that if your work focus on like coming yesterday on image border, you can say that image stitching. Okay, image stitching on something like that. Okay, you can say also, but it's too detail. But it is in general sufficient enough. You say Malaysian rice classification using deep learning and transfer learning. Okay, so your report gonna be look like this. Put your name here, coming, and so on. School of Computer Science, or your company, whatever you want to do, just put it there. This is solely free on you to put your name, your company, or School of Computer Science, and so on. So the first thing is you're gonna put some abstract. Okay, it's very concise abstract. Okay, to represent the whole work. Okay, all right. Then some keyword here. Then you have to move to introduction. So introduction basically you just get intro to your work. Okay. In Malaysia, there are various kind of rice for the population, as rice is one of the main important dish for all the Malaysian. In Malaysia, they got so many type of rice and so on, blah 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 and so on. Alright, then just go on and then you put some introduction here. In this case, is they put some sample here. Recent approach computer vision, machine learning and deep learning have improved efficient image classification tasks. So this is on defected fruit. Okay, detection of defected fruit and classification is very important today, as it used in most farming industry to detect defected fruit, and by having it computerized, it can save a lot of costs. As today, the farmer workers who detecting the fruit is not quite good, on their expertise. And the manual thing is have say 60% of error in detecting defected fruit. And it is important for the farming industry to detect a food in computerized way. Okay, something like that intro, and then you give some picture of the food and so on. Okay, and then you goes on introduction. You just look at here example and look at the context of how introduction has been made. Then you have to do some literature survey. Okay, just find out as many as you can, some related work on nation rice recognition system using deep learning and transfer learning. So, and then if you got it, just list it there. And this is your proposed work. This is where CNN architecture. Okay, we propose in this verse we propose 3 convolutional network architecture. The first is your CNN. Here I say 3. Okay, so the first gonna be your CNN, up to you, and the second one is transfer learning. To transfer learning here, I use VGG16 and MobileNet, and others if any, just 3.1 and so on and on. So here I got 3, 1, 2, and 3. Okay. So the first one, you propose CNN architecture. This is what you're gonna do. So you're gonna propose here. In this case, I propose this paper propose. You got 1, 2, 3 convolutional, and you got a fully connected layer. So I don't know how many layer here, but you can read. You can describe below here. And in this case, you got a fresh apple, fresh banana, 1, 2, 3, 4, 5, 6 classes. Okay. In case of your rice, you're gonna have nasi dagang, nasi what else last time, nasi Terengganu and so on, and how many. So it depends on the number of your group. If you got 5 member in the group, it's supposed to be 5 classes here. Okay. So this is my propose. I propose 3. You can put more, up to you, or 5 or 6 convolutional layer. All right. And then you talk about transfer learning, and then here transfer learning we're gonna learn today. Okay. I'm not gonna discuss this one yet, but this is another tool using a transfer learning, and you're gonna also have your data set. So data set here basically mean your assignment 1 lah. Okay. You just tell here your experience in collecting your assignment 1. Our data set consists of 5 times 300. Our data set consists of 1,500 images, comprised of 5 types, 5 classes, which is nasi dagang, nasi this, nasi this, nasi this. Picture below are some of the example and so on like that. And then in the pre-processing part, I'm formatting the images that we collect into 224 times 224. Okay, and then you can show the picture, and the context of the pictures not really much different. 224 times 224 are the format used in the VG16 transfer learning and so on like that. And we do some augmentation work. So 1,500 is becoming 5,000. Okay. And we divided our data set into 2 portions. The training will be 90% and testing will be 10%. And so on and so on. Okay. And then give some example of your data set. So this basically assignment 1. So in this case, you can put 3.3. You can start here also can. After this literature survey, never mind, you can put like this. You propose work. Then when you have your proposed work, you talk about your data set, your assignment 1. Okay, some sample here. char kway teow. I think this is augmentation, you know, you see and this is not good one since you got black here. It's supposed not to have a black here. It is noise basically. Delete the black one. If you delete this black one, I think this picture, the learning will be better. Okay? Because this black also gonna be learned. It's annoying the learning. Just put it all white and just a banana. That's very good. They got black here. I think it's not a good approach. It is really noise. It is considered noise in this work. And this is okay. And this is the augmentation. So this is under 3.3. You can say here 3.3.1 also can. Or augmentation, or you can say image border stitching, something like that. Okay, more specific. How do you do the border stitching? Say like coming border stitching could be, you can talk about when you do the augmentation, the image is gonna be changed in the form shrinking, and we propose to work what we call a border stitching or border patching. So the step in border patching, basically first we're gonna check the image after we do the augmentation. The checking is basically as follows. You just say it, and then you're gonna take the picture, check the row and the column. Are they different? Are they how much different from row and column? If they differ, let's say 40%, then you're gonna add the border. So how you gonna add the border? So all in detail there. Okay. When you say when you say here just simply the word border stitching, you can write the border stitching in many pages, you know, in detail. How do you check the column, the row? How do you detect that you're not going to see from your eyes all the images and you do the stitching? You're going to have to do the computerize all those things. When you augmentation, the system going to be automatically detect this image is shrinking and so on. So in terms of image patching or image stitching, you can talk about it in number of pages basically. Then you can list down the detailed algorithm. Check the column, check the row. If the difference between column and row is more than 40%, then do the stitching. How you gonna do the stitching? Find the, for example, find the short, compare the column and the row, which one is the short, and then where do you gonna put the stitching and also on. You got 4 border here. So are they like padding or just one column only and so on? So when you talk about image patching, is a lot of things. And here you got augmentation. They show you how they augmentation. So the same picture like this, they're just gonna rotate the picture and so on, change the brightness and so on. All right, because we're gonna augmentation, basically we want to have the the model gonna learn in every sort of angle of the image. Okay. All right, then you have to talk about the performance basically here. How do you set up? Okay, how many rambutan and so on. You can read from here. What computer do you use? I'm using CRAS and so on. Okay, and then what metric you're gonna use? Metric here we have used accuracy with this formula, and we use confusion metric and so on. Whatever you're gonna use and put it here. So in performance result, first experimental setup. Then you're gonna talk about. Then you're gonna put your result. Plot of the graph. When you change the optimizer, what happened? If you change the epoch, just tell it what happened. And at the end of the day, you're gonna have the best, probably the best configuration, the best accuracy. In this case, our CNN is 97. So this is transfer learning. You got 78. Well, this is good, you know. Your proposed model got 97.82% accuracy. Okay. All right. And conclusion and so on. Okay. So this is what you're gonna have, okay? Your assignment, is a project, assignment 2 or project. And I have put more reference here. You can refer. So this is the first. This is the first reference. Okay, and fresh and rotten fruit classification using and transfer learning. There you go. You see, so you can just copy and paste from here. Okay, but make sure you change to your own word because plagiarism detect will be accurate. Okay, you can copy paste here, but make sure you modify. Okay, you modify, not just copy paste and just like that. And changes to your own words. Okay, changing to your own words. Okay, at least plagiarism 20% is okay because there are some word that you cannot change. Okay, and one image can become 8. Yes, can. More than that also can coming. Okay. Yes, one image can become 8 because one image like this, like this, briefing, brightness, and so on. Okay. If you Google augmentation, they're gonna show you some example. Okay. And okay. So this is one of the example of paper you can relate. Easy, your assignment is easy basically. So you can use this in many ways. This is another way, material and method. So these are probably coming from medical background or something like that. Okay. Oh, this is the paper that I have just now. You got put there, and this is what the basic architecture you're gonna have. Okay. Just you can draw like this. You can draw like this, and this is what they have. How they represent their work. Yeah, like this. Okay. They have changed 2 to 4, and they use ReLU and so on, blah 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 and so on. This is just only description of CNN, like in our class. And this is the proposed work they have. And for the transfer learning, they're gonna use a mobile net and so on. Result propose. Okay, and then you can go on. I think it is the same. Okay, you can put anything that you think it is better for you. Okay, and then so this is important. Can have some even if it is higher than the others, it's good. But if it is lower, it's okay. It is just a project. But hopefully it's higher than this. It's good, so we can publish your work somewhere. Okay, so this is one example, and then you got another example, paper 2. Okay, so you got many examples. So this example you can put on your literature survey basically, and take notes that this is what year is it? Not too long, at least 5 years, something like that. And I think for Malaysian rice, you're gonna be difficult to get the support material. When we said Malaysian rice, who's gonna doing that? Only Malaysian people. In England or USA, they are not gonna do Malaysian rice because they don't know our rice. They don't know about nasi dagang and so on. Okay, and so this is what I can't remember. But this is just some of the example of paper you can use for your report, copy and paste. And again, make sure you change to your own word. Don't copy and be like that. And number 3 paper, I think this is another one you can refer to on your report, mango classification. Okay, so this is the other people work. So I think this is quite good work for you to start with. Okay, this is the way how they put the most popular Malaysian rice, the most popular rice food in Malaysia, nasi dagang. I show picture. Nasi, I don't know what. kway teow and so on. So you can put on and on here like this. So this is just a different of presentation. And I think this is this is good, because from here you make the reader understand what are the problem definition. So they're gonna put those popular type of manga, 1, 2, 3, 4, 5. So I know 6, 7, 8. So at least from glance I know this work basically are having 8 classes. Okay, so they go straight to the problem definition. Engage the reader to the most eight mango to be classified in this paper. 8 or 7. 7, okay, 8, okay. So this is one way of representation. I think this is good, They keep focusing on because nasi in Malaysian is a new thing, so it it is good to tell people out there. This is nasi dagang. This is nasi Terengganu. This is nasi goreng Singapore and so on, because they don't know much about the food. So this is you got explained in detail is better than you just simply saying that in 3 lines. We got 6 type of rice in Malaysian. Nasi dagang, nasi this, nasi this, nasi this, that. Only 3 lines. And this is far more better. Not only they say it, but they describe it as well. And here you got one picture, you can put 2 or 3 picture of nasi dagang rice. Okay, so this is then you move to CNN, literature survey, and so on. So this is another way of format of your report. Okay, pooling layer and so on. I think these are all in my notes basically. This is nothing that only on my note. On your note basically, what is the convolutional layer, what is happening there, what is pooling. The purpose is just to got half the size and to delete all unimportant pixel and so on. Even you can put picture here, uh, how pooling is happening there. So we're gonna look at this. This is a model summary. Okay, we're gonna look at hands-on later on. We learn on concept here. So this is what training. This is what. Wow, it's look awkward, This is what. This is the accuracy, and this is kind of very rare, graph. I guess this is not a good journal, so they accept this work. Okay, this we don't see the accuracy is just like that from the beginning. So this is what batch epoch. The first epoch is just one. You see, this paper should be rejected. I think it's not. Do you think so? Coming. How do you agree with this figure? From the zero epoch is straight to one, and there's something wrong with the training, I think.
Definitely not right.
Yeah, definitely something wrong. Probably I think we have to read in detail this paper. How come it become like that? If you submit to the impact factor journal, definitely they're gonna reject this one. Because the pattern is really not like normal. And but this is example. I want you to look at this how they present the work, and you can go on. I got 6 here. Let's say the last one. Okay, the last one is another example you can follow. All right, and yeah, this is one example. Okay, and say no. Okay. Just like my paper there, if they got I got some paper on this one. Okay, I think What is it? I can't remember. Okay, never mind. So let's back on this one. Okay, I got some papers on this deep learning and on fruit. Can't remember. We're gonna check it later. Okay, and okay, I think any question on the assignment? I think you clear assignment. Are you clear on the assignment? It's easy work, you know. I think, yeah, I think it's, if you know the thing is very straightforward. And the code for CNN is just a few lines. And transfer learning we're gonna learn now. Okay.
So, Doctor, I think what you mentioned is more like describing our data, then describe like what are the possible model that we use, and then what are the experiment and the result of
Yeah,
that
yeah,
experiment.
yeah, yeah. I think the most need you to think about is the layout of your CNN. How many convolutional you want? 3, 4, up to you. And how many neural network layer you want? 3,
Yep.
4, and the rest you can follow the paper, the pattern.
Yep.
And the paper, basically the rest is you can follow the paper, how they write, how they present. It is important how they present the paper. The rest, I think the pattern is the same on all paper, you know. The structure, the pattern, the way they represent the word, I think you can just right away paste and copy. Also, you can also just simply follow uh, what they are discussing. They are discussing about batch size, learning rate, epoch, number of layer, number of convolutional layer, number of size of filter, and so on. And so on like that. So you can pick on your own which one you think you can discuss, you put it there. If something you can't discuss, just don't put in here. Okay? So only put something that you can discuss. I think if learning rate you are not really sure what to discuss, just omit it. Put the others. I think number of epoch you can discuss about it. Okay? And and don't forget you have a augmentation effect. So put in a discussion. All right, and
Doctor, we do not need
yes.
to deploy our models into any services, right? We just need to
No,
perform
no, no,
experiment
no,
without.
no, 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 no. So in this case, make a simple one and keep it running so that you can get some plotting graph. Then, okay. So the important is the representation here. It doesn't matter how you perform it. Very simple or nice or whatever. As long you target, you got accuracy and learning rate, accuracy and batch size. As long you get this figure, doesn't matter how you produce it. It's okay. All right.
Okay. Thank you,
Okay.
Doctor.
Okay. Even you draw it yourself without think, people don't know. But you need to draw it look reasonable lah. Okay. Not just like this, you know. Not just like the other paper just now. They go straight from here until it's supposed to be like this, you know. Okay. So that's because people just only want to see result. And when they see result, they can look. This is rational. This is look real. Not very weird. It is a normal like this. All right. Okay. Any more question on? That's why their country is Bangladesh because they have certain of food there. It's not coming from USA because they don't have the food. What is this? What fruit is this? So this is so they don't talk about the food. All right. I think it's detecting fruit. What fruit? Okay. It's not good one, you know. Put some picture here so people can see the fruit. Okay then. I think we're gonna when is the deadline? I'm not sure. Just let's see. I think before we go to study week lah. because let's finish everything in study week. Okay, so we're gonna move on trust learning. So make sure you understand trust learning is important on the. It's very important for your assignment, for your project, as well as for the exam.